Now we started with the carboxylic acid. Okay, so in the carboxylic acid, it is represented with the functional group which is represented by COOH. Okay, generally the carboxylic acid is found in a number of any kind of the natural and the synthetic products. Okay, and they are carboxylic acid is considered as a, or the nature of acid is considered as a like weak acids, and they can easily get react with that alcohol part and allow to formation of the another functional group that is called the ester. Okay, which is the esters have their own properties that the fruity smell, and most commonly this esters is occurring in the any kind of the fats and oil kind of the naturally food products. Okay, and it is stores in the human and the plant body as an energy source. So this carboxylic acid is allowed to be used to react with the OH group and allow to formation of the ester. Okay, that is the general reaction will occur. So this is allowed to take a part of the two of molecule of carboxylic acid and the alcohol to formation of the acid. And the carboxylic acid, which is represented by the COOH group, is generally responsible because, as I told you, all the carbon chain, whenever if it is in a one carbon, single carbon, two carbons, and this is three carbon chain. If any kind of the functional group is attached with that, either it is alcohol, ether, ketone, aldehyde, and ester element, so their properties completely get responsible and depends upon the particular functional group which is attached with the carbon chain. If it is alcohol attached, so the property is chemical property and the reactions depends on that. Say if it is like a carboxylic acid group is attached with the carbon chain, so the generally is responsible for all kind of the chemical property and the reaction nature. Okay. So here with this part, this one the chain is considered as a parent one. Okay, and the acid part is considered as a suffix. Okay, if like for example if you consider the methanoic acid, oic acid is used as a suffix which represented the carboxylic acid, and this one is term is represented methane means the saturated one carbon chain you have, and if it is react with the COOH get attached with that part, that will allow to formation of to remove one hydrogen convert into methanoic acid. Okay, so this will consider as a methanoic acid because it has a two carbon.
Yeah.
Okay, so in that consider as a, if we are consider the methanoic acid, where the formula is considered as a COOH. Okay, same as like general reaction when methanoic acid is represented by this, methanoic acid is represented by that. Okay, and generally this is methanoic and methanoic acid have the high range of the property of the which is work as a representative of the carboxylic acid property. Like for example in vinegar we are using, okay, when vinegars you work as a high dilution form of the nothing but dilution form of vinegar. It's common name we are considered as a acetic acid also. Okay. In vinegar what we are considered we are taking the like 10% solution of this ethanoic acid allowed to formation of the vinegar. Okay, which is used as a preservative for the pickles and any kind of the materials for the packaging material foods we are using. Okay, the vinegar as a preservatives. And if I consider how this kind of the properties of the carboxylic acids get represented by the vinegar. Vinegar is just like an example of the carboxylic acid because it's just a complete pure form of acetic acid in the diluting nature. Okay, means like approx you having the 10 ml of the this ethanoic acid and 90 ml you are adding the water and that's allowed to get converted into the same as carboxylic acid have like unpresentation in it because it tastes like a vinegar and sweet shock and runs in little bit bitter taste. Okay, it have. Okay, and the carboxylic acid nature is considered as a weak acid because whenever acid's property is considered as a giving the H plus sign. Okay, who will give the very strongly H plus ion, so they are considered as a strong acid. But the carboxylic acid nature is not so strong, so that's why to give the H plus ion, so that's why they are considered as a weak acidic property. Okay, it means the dilution solution of the carboxylic acid have the very high pH rate because as acidic range we know of pH is 0 to less than 7. Okay, so in that case we are considered as because the carboxylic acid have a weak acid means if you are making the dilution of carboxylic its pH range become higher. Okay, means its acidic properties get reduced. Who have strong acid like for example HCl, H2SO4. Okay, so these are considered as strong acid because their dilution form is also pH range is low. Okay, and this weak acid nature because as I give you the acid nature means who give the H plus ion. So carboxylic acid have a property is less to give the H plus ion, so that's why weak acids are considered as a less reactive as compared to the strong acid like HCl, sulfuric acid, H2SO4. So because they are very easily give their H plus ion, so they are considered as more reactive as compared to the carboxylic acid. Okay. And whenever they are allowed to form, they'll show all type of the reactions of acids which is performed by the strong acids but not so much reactive as compared to the strong acid. Now the first reaction we discuss about that carboxylic acid perform reaction with the metal. Any acid when react with the metal, they always will form salt plus hydrogen gas. Same reactions is done by the carboxylic acid. For example, you having the ethanoic acid, which is also called acetic acid, means CH3COOH. Okay, and now you are reacting this one. We are taking the two molecules of gas and we are reacting with the magnesium. Okay, now this is allowed to magnesium remove this hydrogen and it is allowed to form magnesium ethanoate. Means these two ethanoic compound is attached with the magnesium and one molecule of hydrogen gas is released. So this is considered a salt of the magnesium ion and this is considered a hydrogen gas to form. Okay. And the next reaction is occur with performing by the carboxylic acid. That one is when an acid is react with the soluble hydroxides. Means hydroxides means which is having the bases. Means whenever acid react with the base, they always allowed to form salt plus water. Okay. Same as you are running the reaction with the ethanoic acid like CH3COOH and you are reacting with the sodium hydroxide NaOH. Okay. So what we'll do, this sodium is replaced this hydrogen, it will move to this side and the sodium gets changed the hydrogen position. So now the compounds is formed CS3 CONe N1HOH. So the hydrogen comes to the OH side, means it is allowed to form one water. Okay, so means whenever like any kind of the acid will react with the base, they always form their salts and the water. But the salt's nature is not so much strong, okay, because here they are considered as a base you are taking, NaOH is a strong base, and the ethanoic acid is work as a weak acid.
Yeah.
Okay, so because basic nature is more strong than the acid nature, so what the salt is formed here in salt nature, we have some kind of the basic properties strong. Okay, because you have in the strong base here. If both are strong, so they are allowed to form the neutral salt. If both are weak, that is also allowed to form the neutral salt. But if one is weak, one is strong, so who is strong, whose nature is get dominant on the another one character. Next part we are considering next reactions performed with that. That one is when the acid react with the carbonates, means with the metal carbons. Carbon is represented by the CO3. Okay, means for example any metal is considered as a, you have the MgCO3 and any kind of the CaCO3 you have. Okay, so any metal carbonate you have, and whenever the acid will react with that, they will always allow to form salt, water plus carbon dioxide. Same as like ethanol you have, okay, which is formula is CH3COOH, and you are reacting with the calcium carbonate, whose formula is CaCO3. Now this one is allowed to react because here the calcium is subcharge is +2, so it's made of 2 molecules of ethanoic acid. We are taking 2 molecules of this one. Okay, so it is allowed to remove 2 hydrogen this side. Okay, so the formula will come CH3CO will get attached with 1 calcium ion, okay, and 2 hydrogen. When it's replaced from this side, it will take 1 oxygen from the carboxylic carbonate ion, and it will allow to formation of 1 water molecule. And 1 oxygen when it gets removed, which is taken by the hydrogen, so it is having now CO2. So that one is salt, that one is water, and that one is carbon dioxide. Okay, so these all these three are the general reaction of the acid. When acid reacts with a metal, always form salt and hydrogen gas. Whenever the acid reacts with the base, always form salt and water. Whenever the acid reacts with the carbonate, they will allow to form salt, water, and the carbon dioxide. Okay, but the product which is formed in the salt nature, that is not so much like a strong neutral salt. Okay, because the acid you are taking, which is taking a part in this type of reaction, this acid nature is weak. Okay.
Yeah. Mm-hmm.
Next one you consider as a, I say the primarily will discuss about the ester formation, which is considered as a esterification reaction. Both carboxylic acid and we are considered as a alcohol. When both allow to take a part in reaction, they will allow the formation of the ester and the water. Okay, so this type of reaction is termed as esterification. For example, you are having CS3COH. Now you are reacting with the C2H5OH ethanol. That one is ethanoic acid and that one is ethanol. When both allowed to get react to each other, will allow to remove the water molecule from that side. Okay. And then they get attract to each other, so the formula comes right in the water molecule out. This group is considered as a ester. Okay, means they can consider as a generally we can represent it because carbon chain you can represent by the R in alkyl chain. So here you can write down like this because both R chain is different from each other. So one side you can represent by R and one side you can represent it by the R dash. Okay, that is the general formula of ester, which is sweet in smell and is most commonly take a part in the number of reaction and work as a preservative also. Okay, so that's the most common application of the carboxylic acid and the alcohol, which both are take a part equally in this particular reaction and allow the formation of the ester.